Alright, today we jump all the way to chapter 11. We finished chapter 7 the other day. We jumped, yeah, what happened is those were the optional ones, so we just skipped them there. They're too easy for you guys. So. No, this one's not, for example. Section 11.1, properties of exponents. Alright, well, you already know some stuff about exponents, don't you? So, for example, if I asked you what's 4, and I put a little 3 up there, what would you tell me? It is 4 cubed, and what does 4 cubed mean to do?
It's 4 times 4 times 4.
It means 4 times 4 times 4, which happens to be 64. There's the correct answer, 64. 4 times 4 is 16. 16 times 4 is 64. Or if I gave you 2 to the 7th.
128.
128?
Yeah.
Because it means 2 times 2. 2 times 2 is 4, 5, 6, 7. So having an exponent up here that's a nice number just means multiply by yourself over and over and over again. And you're sure that's 128?
Yes. Because 2 to the 8 is 6.
All right. I'll trust you. I'll trust you again. I got burned a few minutes ago, but I'll trust you again anyway. 128.
Actually, it's 128.
All right. So our first definition. X to a power equals x times x times x times x. As long as the power is a nice number like 1 or 2 or 3 or 4, so on and so forth. Having x to a power is just a shorthand way for multiplying over and over and over again. Just like multiplying is a shorthand way for writing adding over and over and over again. Adding is, it's a basic thing. You stuck with that. No way to go away from it. Just a special way to capitalize that. Subtracting and so what if I asked you to take 3 squared and multiply it by 3 cubed? You add the exponents when you're multiplying? How come? Just because?
Because if you write it all out, you've got 3 times 3. You multiply that by 3 times 3 times 3.
That's correct. If you write it out, 3 squared means 3 times 3. And 3 cubed means multiply 3 3's together. So when you write it all out, how many 3's are you multiplying together? 5 of them. So that's 3 to the 5th. So you're absolutely right. The rule is when you're multiplying things and these numbers are the same, the 3's match, there's a name for that. Anybody know what those numbers are called? Not the coefficients. Coefficient is a number in front of a letter. When we're dealing with this is called the 3 here is called the exponent. Anybody know what this 3 is called? It's not the opponent, the exponent and the opponent. This is called the base. So if the bases are the same, in this case this base is 3 and this base is 3, if the bases are the same, when you multiply you add the powers. So we're going to have a long list of rules here. Rules. Number 1. X to the A times X to the B. You add the powers. And I'm going to leave some space here because we're going to have more rules. 2, 3. I don't know how many we're going to have. 7? Alright, let's see if I can come up with 7 rules. I don't know how we're going to have. Alright, so for example, if I asked you to take x to the 6 times x to the 4, you would tell me the answer is x to the 10. When you're multiplying things with the same base, you add the exponents. That's x to the 10. If I asked you to take 4x cubed times 7x to the 5th, you multiply the numbers out front. 4 times 7 is 28. And then you add your exponents, x to the 8. What if I asked you to take negative 5x squared y to the 6th, and multiply that by 2x to the 7 y to the 5th. Negative 10 x to the 9 y to the 11. That's correct. So we would multiply the numbers out front. That's negative 10. Add the powers on our x's. Add the powers on our y's. Questions about that? What's that? It should not correlate against me? Well, I don't think they did. So. What if I gave you 2 to the 5th and asked you to divide that by 2 cubed? 2 squared. Why 2 squared? Well, that makes a lot of sense, doesn't it? When we have the base the same and we multiply, we add the exponents. It makes a lot of sense to say, well, if we're going to divide, we should then subtract. And that's actually true. That does work. And you can just do it this way. 2 to the 5th would mean multiply 2 5 times. And 2 cubed would be multiply 2 3 times. And then you can take 3 of the 2's out. So you can, and you're left with 2 times 2, which is 2 squared. All right, so there's rule number 2. If I have x to the a, and I divide by x to the b, I get x to the a minus b. And for this little rule, we have to have a little condition. X cannot be the number 0. How come x cannot be the number 0? I can't have 0 on bottom. I can't divide by 0. X can't be the number 0. All right, so this would look like so. What if I gave you x to the 10 divided by x to the 4th? You would subtract your exponents and you would tell me it's x to the 6th. What if I gave you 21 y to the 8th divided by 14 y to the 5th? Whatever 21 divided by 14 is, what's 21 divided by 14? 1.5. I would prefer if you just reduced top and bottom by 7 and wrote it as 3 halves. And y to the 3rd up on top, because 8 minus 5 gives 3. All right. Oh, let's see. What if I had 6 x cubed y to the 4th times 3x y to the 6th divided by, I don't know, 70 x squared y to the 5th. I almost agree with that. It should be x to the 4th. Why x to the 4th? Because we have 3 x's here, we got 1 more x there, we add our exponents, 3 and 1 makes 4. Over 70 x squared y to the 5th. What's 18 divided by 70? 9 over 35, I can reduce top and bottom by 2. 9 over 35, x squared, y to the 5th. Questions on that one? Okay. How much is 5 cubed over 5 cubed? 5 cubed over 5 cubed is 1. Why is 5 cubed over 5 cubed 1? When you divide any number by itself, you always get the answer 1. At the same time, 5 cubed over 5 cubed, what happens if I subtract those exponents? I get 5 to the 0. So, since 5 cubed over 5 cubed is 1, and 5 cubed over 5 cubed is also 5 to the 0, what does 5 to the 0 have to be? 5 to the 0 is the number 1. That's the next exponent property. Is there anything special about the number 5? Could I have done this with every other number?
Yes.
Every number except one of them. I couldn't have done the same trick with 0. Why not? It's my special number. Can I have 0 on the bottom of my fractions? No, I cannot. Alright, so this is rule number 3. X to the 0 is the number 1. And again, we have to have the little rule, x cannot be 0. What if x is 0? How much is 0 to the 0? 0? What's 4 to the 0? What's 3 to the 0? What's 2 to the 0? What's 1 to the 0? 1. What's 0 to the 0?
0. 0.
Why does the pattern suddenly change?
Because it just does. It's math for you. Math is weird.
Well, it seems like the answer should be 1, right?
It should be.
What's 0 cubed?
0.
What's 0 squared?
0.
What's 0 to the 1?
0.
What's 0 to the 0?
0.
Alright, so we have a problem.
Yeah, we do.
It depends on which pattern you look at. Sometimes it looks like 0 to the 0 should be the number 1.
But it should be
Sometimes it looks like 0 to the 0 should be the number 0.
0.
So which one's the right answer?
0.
No?
You lie. 2.
2 is not the right answer either.
This could be like 50. It's 50. Not 1.
0 to the 0 is undefined. You can make a good argument that the answer should be 1. You can make a good argument that the answer should be 0. Typically when that happens in math, we just say, well, then we're not going to talk about it. We don't fight in math classes. If there's 2 right answers, we just say we won't take either of them. I just did.
Yeah.
I just did, right there.
You should. You should be able to.
Got one?
It isn't math. It is not now.
Is it? No. All right. Rule number 4. Ooh, negative exponents. What a wonderful idea. So if I gave you 3 squared over 3 cubed, what would 3 squared over 3 cubed be? 1 over 3? Is that what you said? All right, well, I'm just going to do it this way. 3 squared means 3 times 3. That's 3 times 3 times 3. I can reduce that one with that one, that one with that one. I'm left with 1/3. On the other hand, same sort of trick, 3 squared over 3 cubed. I use my subtraction rule. That's 3 to the negative 1. So negative exponents do not give negative answers. It's a very common mistake that people make. Negative exponents make fractions. So 3 to the negative 1 is 1 over 3 raised to the 1, which is just 1 over 3. So what the negative exponent does is it just takes the thing and pushes it to the bottom. So how much is 5 to the negative 2? It's 1 over 5 squared. The square pushes that to the bottom. And 5 squared is 25. So we would write that as 1 over 25. All right, so that's rule number 4. If you have x to a negative power, it drops it down to the bottom. And again, like all these other rules, x can't be 0. I can't have 0 down on the bottom. Poor 0, he's all alone, all by himself. Nobody wants to play with him. All right, so typical problem you're going to see is going to look like this. Simplify. Writing answers using only positive exponents. So I might ask you, what's x to the negative 4 times x squared?
Well, it's going to be 1 over x to the 4.
That's correct.
Which would just be x squared over x to the 4.
That's also correct.
Which means x squared at the bottom.
Which means x squared on the bottom. What you did is perfectly correct.
But it's wrong.
No, it's not the way I would have done it. All right, so what he said is, I'll do it your way. He said that negative exponent drops that to the bottom, which is absolutely correct. And then he noticed he had x squared over x to the 4th, which is going to do what?
X squared at the bottom.
It's going to leave you x squared on bottom. Why x squared on bottom?
That's what it is.
Because you got more x's down on bottom than you do up on top. All right, so the answer is going to be 1 over x squared. Perfectly correct answer. The way I would have done it is I would have said, I'm multiplying two things together, I add my exponents. So that gives me x to the negative 2, and then the negative drops it to the bottom. Which way is correct?
Both.
Which way is better?
Mine. I mean, ours both.
Just kidding, I like yours better. It makes more sense to me.
Okay. The truth is, which way is better is whichever way looks easier to you. They are both absolutely correct. And that's one of the things about these problems that we're going to have today. For most of the problems, there are multiple different ways to do them. As long as you follow the rules, you'll get the right answer. And they're all correct. All right. So this is the way I tend to do it. If I had y to the 5th times y to the negative 3 divided by y to the 4th. All right, so you like to move things top and bottom, okay? All right, so he saw that this thing had a negative exponent. Negative exponents go down to the bottom. And then what would you do? Combine the bottom ones. It's y to the 5th over y to the 7th. You reduce. You notice the bigger power is on bottom, so you're going to have stuff left over on bottom when you're all done. And you can cancel out 5 of them, so you're going to have, 2 of them left down on bottom. Or we could have done it my way. To do it my way, I would have said y to the 5th times y to the negative 3 divided by y to the 4th. I would just go ahead and multiply right on top and add my exponents and say that's y squared over y to the 4th. And then I would notice my bigger power is on bottom, so I'm going to have stuff left over on bottom, and I can cancel a y squared out, and I'm left with a y squared on bottom. Again, which way is right? They're both right. Which way is better? Whichever way makes more sense to you is better for you. Is neither of those?
It's not.
It's not one of those? It isn't not one of those. All right, what if you have a negative exponent and it's already on bottom?
Still flip it.
What do you mean you still flip it? Flip it how?
It's 1 over 1.
All right, so this would be 1 over 2 to the negative 1 is a 1/2. Now, how do I take a nice number like 1 and divide it by a fraction like a half? I flip and multiply. So this becomes 1 times 2 over 1, which is 2. So, what happens when you have a negative exponent on bottom? It just moves to the top. Alright, so negative exponents just interchange top and bottom. If I have 1 over x to a negative power, it goes to the top. And again, I can't divide by 0, so poor old 0 gets left out of the fun here. So, negative exponents. The only thing negative exponents do is interchange top and bottom. Alright, so if you had something like this, some big mess, 4y to the negative 3 over x to the negative 6, y to the negative 5.
So you get an x to the 4, x to the 6, so on top of
Yeah, I think a good idea with something like this is to just move things. Get rid of all the minuses to begin with. The x to the 4, that one doesn't have a minus sign, does it? So where does it go? It stays exactly where it is. This y to the 3rd goes down because it has a negative exponent. X to the negative 6 goes up because it had a negative exponent. And y to the 5th goes up because it had a negative exponent. So I think that's a good idea to get rid of all the negatives right away. Just move things, interchange top and bottom. If you have a negative on top, it goes to the bottom. If you have a negative on bottom, it goes to the top. And then I can reduce. X to the 10, y to the 2nd. On my x's, I add my powers. On my y's, I subtract my powers. There's my answer, x to the 10, y to the 2nd. Questions on that one? All right, how about negative 12 x to the, I don't know, give me a good number. 7 y to the negative 6 over 4 x to the 6th y to the 6th. Okay. How would you simplify that?
Well, first you do the numbers.
First you do the numbers.
Divided by 4, you get -3.
Negative 12 divided by 4 is negative 3. Does it move to the bottom?
No, stay the top.
Why does it stay on top? It's got a negative.
There's no negative exponent.
It's not a negative exponent, is it? It's just a regular old negative number. If I just gave you negative 12 divided by 4 without all the rest of that stuff, you would just quickly tell me negative 3. It doesn't move, it's just negative 3.
It's also and then you can do the x's first.
I can do the x's.
You got x on.
I got x to the 1.
Yeah, but then you move the y down to the y.
Alright, and so I already have a y to the 6 down on bottom. But this one's going to move down. I'll have another y to the 6 down on bottom. Final answer is negative 3x over y to the 12. Questions on that one? Alright, we had 7 things listed for rules. I think I only have 6. I think I only have one more. Oh well, we guessed. What if I gave you 3 to the 5th and I told you to square that?
Ooh, that's where you multiply the exponents.
That's where you multiply the exponents? Why is that where you multiply the exponents? That's not a significant rule for me. What's that? Alright, so this would mean squaring something means multiply it by itself. So that would be 3 to the 5th times 3 to the 5th. And then we use our old rule that says add the exponents, 3 to the 10th, which is the same as 5 times 2. 5 times 2 is 10. So you're right, there's rule number 6. Rule number 6 says if you have a base and it has a power, and then it has another power, so I guess I'll use P and Q there. You multiply those powers. X to the P times Q.
So we got to pull that seventh rule.
Seventh rule?
Just make up the rule.
Okay. 0 to the 0 is undefined.
There you go. See?
There we go. We had a seventh rule. 0 to the 0 is undefined. All right. So that last rule,
Which one is
the sixth,
This one last.
the next to the last rule.
the second from last?
All right. So we have something like this: negative 4 x to the 6 y to the negative 2, whole thing squared.
Negative 16, 1 to the 12.
I almost agree with you. Positive 16. Why positive 16?
Oh, yeah, never mind.
Negative 4 times negative 4 is positive 16. And then we multiply those powers, so that's x to the 12. We multiply those powers, y to the negative 4. 16x to the 12th. The y goes down on bottom because it has a negative power, so y to the 4 is down on bottom. All right, what if I gave you 2x to the 4th over 3y to the negative 2, and then the whole thing has a negative 3 power around it.
We got 1 over 2 to the third. Yeah, I have root 2.
Okay. All right, so
My way sucks.
no, your way is good. What you're doing is you're taking this exponent and you're whacking it with everything, which is exactly what you should do. Except I'm just going to write it right now. I'm going to write it as 2 to the negative 3, x to the negative 12, over 3 to the negative 3, y to the positive 6, because negative 2 times negative 3 is positive 6. So I would get rid of that parenthesis thing first, and then I would worry about moving stuff. Now I move stuff.
So the 2 goes up on the
So the 3 cubed comes up on top, and the 2 cubed goes down on bottom.
yes.
The x to the 12 goes to the bottom. Y to the 6 stays on bottom. And then I can deal with the numbers. 3 cubed happens to be 27. 2 cubed is 8. X to the 12, y to the 6 is how I would write my final answer. So don't let it worry you if you have a big parenthesis like that with a negative exponent outside. Take that negative exponent, run it through, and then simplify. All right, what if I give you a mean question? Two a to the negative 1 plus 3a to the negative 2.
So you would have 2, 1 over 3, plus 3.
So I can just write that as 2 over a plus 3 over a squared. Okay.
And then you just multiply the first one by a
He's just watching. Yeah. So you're right. Now that I've done that, now I have to have a common denominator. My common denominator is a squared. So I have to multiply this fraction, top and bottom, by a. And then I can add them. So my answer would be 2a plus 3. I can't add those together. They're not like terms. Over a squared. What if I was even meaner than that? Let's say I gave you 4x to the negative 2 plus 2x to the negative 3. And then the whole thing
Negative 6.
raised to the negative 6 power.
Distribute that negative 6 out.
What do you mean distribute that negative 6 out?
So 4 to the negative 6. X.
Let me ask you a question. If I have 4x plus 2 and I want to square it,
Yeah.
do I get to just square this one and square that one?
No.
No, what do I have to do?
It's 4x plus 2.
It's 4x plus 2, 4x plus 2, and then I have to FOIL it out and do that work, don't I? So if I have something with an add or subtract here, do I get to take this exponent and just distribute it through? No, I do not, unfortunately. So do I just get to take this negative 6 and distribute it through?
No.
No, I do not, unfortunately. My final answer is going to be 1 over that 6 times. But before I do that, before I give that answer, I'm using the word that too many times, I would simplify inside my parentheses first.
It would be 4 over x squared.
All right, so we're going to write this as 4 over x squared
Plus 2 over x.
plus 2 over x cubed.
We just walk out those
And then, absolutely right, I would get a common denominator. So I multiply this one top and bottom by x. And I'm left with 4x plus 2 over x cubed. All right, but I think we can do better than that. We can. Because, imagine if I just had that. What would that negative exponent do to the 4x plus 2? It would move it to the bottom. And what if I just had a fraction, this x cubed on bottom, what would the negative exponent do? It would move it to the top. Again, negative exponents just flip tops and bottoms. So I think I would write my final answer as x to the 18, because when I multiply this, I'm going to have a 3 times a negative 6. That's going to be a negative 18 down on bottom. Down on bottom with a negative that moves to the top. Over 4x plus 2 to the 6th, and I definitely do not want to try to FOIL that thing out 6 times. It would be a big, long, ugly mess. I would leave it just like that. You would do it? Okay, well, you can do it. The important thing is, this exponent right here, you cannot just distribute it over a plus or a minus sign. If this were a multiply right here, then you could just distribute it. If you have an add or subtract inside your parentheses, exponents don't distribute, unfortunately. So you've got to clean up inside the brackets first, and then do that exponent at the end and flip things if you need to. Questions? Before I give you problems to do. Problems.
Just give us your problems.
Pushing all your problems
All your problems out with you guys. Yeah. My personal counselors.
How much you pay us?
Nothing. You pay me.
Kangaroo court. Kangaroo.
I'm just trying to figure out what the order is. That one was first.
Yeah.
And I think it was Those. I think that's the order.
Number of my pages. Oh, I guess I can toss this now.